See that jet engine flying through the sky? Or that shiny watch ticking away on your grandfather's wrist? Both start out as something that looks like plain black sand. Hidden inside that sand is titanium, a metal that's as strong as steel, half the weight, and doesn't rust. But how do we turn this pile of sand into one of the toughest and most useful materials on Earth? The answer involves extreme heat, clever chemistry, and some serious scientific wonder. Every year, hundreds of thousands of tons of titanium are made for airplanes, submarines, rockets, and even medical implants. It's expensive to make, but when you need something that's strong, light, and lasts forever, titanium is the go-to metal. Titanium is one of the most useful metals we have, but it doesn't come ready-made. It's hidden inside minerals called rutile and ilmenite, which are often found along coastlines where waves and wind have gathered them into sandy deposits. Big producers like Australia, South Africa, Sierra Leone, Russia, and Japan mine these sands to extract titanium, the starting point for everything. The first step is to clean and refine the sand until all that's left is a white powder called titanium dioxide. Fun fact, this same powder is used in toothpaste and sunscreen. But don't freak out. This powder is non-toxic and perfectly safe for skin. It's just in toothpaste for pigment and sunscreen to block the sun's UV rays. Back to our main topic. Even when dug up from the ground, titanium doesn't like to come out easily. It clings to oxygen and other minerals like glue. To break it free, engineers react the powder with chlorine gas at blazing temperatures of around 900 degrees. The result? A strange, ghostly liquid called titanium tetrachloride, or tickle, as scientists call it. It's so volatile it fumes in air, but without it, pure titanium would be impossible. Now comes the real magic. Inside sealed furnaces running near 1,000 degrees. Tickle is mixed with molten magnesium. Over days, a hidden reaction takes place. The chlorine is stripped away, leaving behind something extraordinary. A brittle gray material that looks like dried coral. This is called titanium sponge. It might not look impressive, but it's now essentially pure titanium metal. The gray sponge will next be crushed, pressed, and then melted in giant vacuum arc furnaces so hot they rival a volcano at over 700 degrees. Instead of flames, these furnaces use electric arcs, which are bolts of controlled lightning that blast through the metal. Each melt takes days and consumes as much electricity as the neighborhood you live in, just to produce a few massive titanium blocks. So much energy, and it all came down to huge solid ingots weighing up to 15 tons each, flawless enough to be turned into parts for airplanes and rockets. Those giant ingots are far too bulky to use directly, so they're hammered, rolled, and stretched into new forms. Imagine squeezing steel through a pasta maker, but with forces strong enough to crush cars into smithereens. The titanium becomes thin sheets for airplane skins, long rods for industrial machines, and wires thinner than a pencil lead for delicate medical devices. And you know what's surprising? The same metal that can withstand jet engines at 600 degrees can also sit safely inside the human body without causing rejection. That's quite a huge turnout, from weird-looking sponges to flying miracles. Literally. Pure titanium is already strong, but engineers discovered that when you mix it with just a little aluminum or vanadium, it becomes something extraordinary. These titanium alloys don't just hold their shape, they survive the extreme heat inside jet engines, where temperatures can soar above 600 degrees. That's hotter than molten lava would stay liquid, yet titanium parts remain solid and dependable. Today, even advanced 3D printers can build complex titanium components layer by layer, creating shapes impossible to forge with old methods. The outcome? Lighter airplanes, faster spacecraft, and stronger machines, all thanks to titanium's hidden superpower. the ability to get even better when mixed with the right partners. But titanium's marvel isn't just for space and sky. It has another secret ability. It never rusts in salt water. Ships and submarines that would crumble if made of steel can dive safely for decades thanks to titanium's natural armor. And here's something even more surprising. Titanium is so friendly to the human body that bone cells will actually grow around it. That's why doctors use it for hip replacements, dental implants, and even heart pacemaker cases. Titanium becomes part of us, literally bonding with our skeletons. From the deepest oceans to the inside of our bodies, it's one of the only metals trusted to survive and even thrive where no other metal can. Making titanium isn't cheap either. It costs nearly 30 times more than steel, and each run consumes enough electricity to power a small town. But when the stakes are this high, jet engines, submarines, human implants, there's no room for mistakes. Every single batch is scanned with X-rays, tested with ultrasound, and stressed until it bends or breaks. Even the tiniest flaw, invisible to the human eye, can decide between safety and disaster. Only titanium that passes these brutal tests earns a place in the world's most extreme machineries. Factories today can turn out thousands of tons every year, yet each piece of titanium carries the same promise: absolute reliability. They say nothing good comes easy, so likewise this super metal comes at a cost. Making titanium is one of the most energy-hungry processes in modern industry. Each furnace burns hotter than a volcano and uses as much electricity as a small town, just to make a few tons of metal. And the chemistry is messy. The Kroll process depends on chlorine gas and magnesium, leaving behind mountains of toxic byproducts that must be carefully stored. That's why titanium can cost up to 30 times more than steel. To fight this, engineers are finding smarter ways forward. In Japan, researchers are perfecting electrolytic furnaces that run on renewable energy, reducing both heat and waste. In the US, aerospace companies are recycling titanium from retired airplanes and scrap offcuts, turning yesterday's wings into tomorrow's jet engines. And in Europe, labs are testing new FFC Cambridge methods, which use electricity alone to strip oxygen from ore. No chlorine needed. The future of titanium isn't just about making it stronger. It's about making it cleaner, greener, and sustainable for a world that depends on it. So the next time you see a jet soaring above, or hear someone in your family just got an implant, remember, it all began with a handful of black ores. Through fire hotter than volcanoes, chemistry that dances at the atomic level, and engineering driven by human imagination, that sand becomes titanium, one of the strongest, lightest, and most extraordinary metals on Earth. From gleaming accessories to body implants, from ocean floor to outer space, titanium is proof that with enough ingenuity, the ordinary can truly become the extraordinary. And perhaps the future itself is already being built, atom by atom.